Data Analysis Algebra 1 EOI Review. In the breakdown of how many questions they're going to ask on the EOI, we're looking at Standard 3, Objective 1, which is under Data Analysis, Probability, and Statistics, and Objective 1 is just data analysis. So we're going to be looking at graphs. We're also going to be looking at a little bit of probability. And our measures of central tendency, mean, median, mode, and range. When answering questions about tables and graphs, it is very important to read the question carefully and understand what is being asked. Do not just try to rush through these. They should be some of your easy or easier problems if you are careful. So if you're paying attention and make sure that you understand what they're asking you to do, these problems should not be too terribly difficult for the most part. A couple of them might be a little challenging, but if you take your time and think through the problem, then you should be just fine. The stem and leaf graph shows the noontime temperatures of a 1-month period in Norman, Oklahoma. Most stem and leaf plots are going to be given with a key. So if you notice, if you look at the key, we have an 8 would be the stem and a 3 would be the leaf. So what that's telling us is if the stem of 8 and a leaf of 3 equals 83, then all of my stems are going to be in the tens place and my leaves are going to be in the ones place. You have to be careful and make sure that you read those because sometimes they'll try to be a little bit tricky, but they shouldn't be too bad. Which of these is not an advantage of presenting the data in a stem and leaf graph? A says the shape of the data is apparent. The shape means how many numbers or temperatures in this case are towards the lower end, how many are towards the middle, how many are towards the higher end. And you can definitely see that in this stem and leaf plot. You can tell that most of the temperatures were in the 70s. You can tell that only 2 of the temperatures were in the 60s and so forth. So the shape is pretty apparent. It's important they like to use the word not on here. So it says which of these is not an advantage. Because the shape of the data is apparent would be an advantage, A cannot be my answer. B says it is easy to find the mode of the data. Remember the mode is the one that appears most often. In a stem and leaf plot, they're already ordered for you, so all of the same numbers would be right next to each other. If you notice from just by looking at this for about 2 seconds, I could tell you that 4 days there was a temperature of 79, which is going to be larger than any other temperature, or there's going to be more 79-degree temperatures than any other temperature. So B can't be my answer because that would definitely be an advantage. C says the temperature are organized from least to greatest. Again, that is true for my stem and leaf plot, so it can't be my answer. And D says it is easy to determine which day of the month had the greatest temperature. This stem and leaf plot has nothing to do with what day the temperature was 68 or 76. It is simply telling us the temperatures. So D is our answer. It is not an advantage because we do not know the days that the temperatures, that was the noontime temperature. The next example says, James made a circle graph showing how he spent last month's allowance of $80. So if you just take a second and look at that circle graph, you know that the smallest amount of money went toward gas. The largest amount of money went toward clothes. Food was 10%, gifts were 20%, and movies were 25%. It says which graph best reflects the information in the circle graph. Just by taking a quick glance at these and kind of reading the titles and the axes, A and B are both looking like they could be my answer. They both are James allowance. Expenses would be on the x-axis and they're labeled appropriately, and the money spent would be on the y-axis or your vertical axis, and they're both also labeled appropriately. C is not going to be my best choice here. I don't really need a scatter plot to display this data. It does not really making sense. So C is going to be out. And then if you look closely at D, notice it says expenses on the bottom And then we have 0, 10, 20, 30, 40, 50, and then it says money spent in dollars for my vertical axis or the y-axis, and it says clothes, gifts, movies, gas, and food. Well, money spent isn't clothes. So D is out because the axes are labeled all sorts of crazy. So let's go back and take a closer look at A and B. A and B are going to be pretty close. Now, you could set up a whole bunch of proportions or multiply 80 by 0.4 to find how much was spent on clothes, multiply it by 0.2 to find how much was spent on gifts, and so forth. Or you can look at the relationship between the numbers. If you look at clothes and gifts alone, it says the amount spent on gifts should be half as much as the amount spent on clothes. So if you look at A, it looks like A says he spent about $31, $32 on gifts and on clothes, I'm sorry. And for gifts, the expense, it would be about 16. Well, that's pretty close to half. If I thought it was about 32 and 16, that would be half. If you look at B, clothes, it says he spent, again, about $32. But then if you look at the gifts bar, it says he spent $20, which is going to be much more than half of my 32. So my best answer here is A. Like I said, you could go and actually find the amount of money spent in each category and then figure out which one, or you can look at the relationship between the percentages and figure out how that would correspond to the relationship with the bars. So my best answer here is A. Box and whisker plots. Remember, a box and whisker plot shows how a set of data is distributed and breaks it into quartiles or four pieces. The first and fourth quartile are going to be your whiskers, and the second and third are in the box with a line at the median separating them. I have a diagram of a box and whisker plot here on the next slide. So the parts of a box and whisker plot. Notice a box and whisker plot is always going to be above a number line. And then this funky thing that looks like kind of like a box and whiskers is the actual graph. So if you look at this, the smallest number is represented on the far left side of your whisker. This line in the middle would be the median of this set of data. So just by looking at this number line and where that line is, I could say the median is 10. And then this last point over here on the right side is going to be the largest number in your set of data. Notice 4 different sections are created in the box and the whiskers. So this going from left to right, you would have your first quartile would be the first whisker that appears. The first half of your box before the median would be the second quartile. The third box would be the third quartile. And then the last whisker would be the fourth quartile. To find quartiles, what you're going to do with your set of data is you're going to first find the median, and then you're going to break up your data into 2 parts from the median. So the part to the that would be less than your median, you would then find the middle of that, and that would become the breaking point between your whisker and your box. And then for the second half after the median in your set of data, you would again break that in half or find the median of that section, and that would be where your box would end and your last whisker would begin. This says the box and whisker plot below summarizes the ages of the members of a health club. So members' ages, we have a box and whisker plot. Just by kind of looking at it, you could tell that the youngest member was maybe 17, 18, and your oldest member is probably about 89, close to 90. The median would be somewhere around 34 probably, and then you can also tell the quartiles that they're broken up into. So what information is conveyed in this box and whisker plot that is not conveyed in a bar graph of the same data? A says the mean age of members. Well, we can't find the mean age of members based on this box and whisker plot, so A is out. B says the median age of members. Because the median age of members is very obvious in a box and whisker plot, I'm going to go ahead, and that could possibly be my answer. I'm going to go ahead and read the remaining two answer choices though. C says the most common age of the members. Well, you can't really tell the most common age of the members from a box and whisker plot, and that would be really apparent on a bar graph. So C would not be my answer. And D says the number of members of the health club. Well, based on this box and whisker plot, I can tell you how the ages are broken down, but I can't actually tell you how many members this club has. So D is not going to be my answer, which leaves me with what I thought was going to be my answer, B. This example says Brian recorded the maximum temperatures each day for 14 days and made this graph to display the results. So the high temperatures and day 1 through 14. It says between which 2 days did the maximum temperature change the most? Now, read these carefully. Change the most means it doesn't matter whether it's increasing or decreasing, just which one did it change the most. Sometimes it might say which one did it decrease the most, and then you would only be looking at the lines with a negative slope or going down. And then sometimes it might say between which days did it increase the most, and then you would only be looking for a positive slope or when the temperature was going up. This one doesn't specify, so we could either have a change in temperatures when temperatures dropped, or a change in temperatures when temperatures rose. If you notice, probably something that stuck out to you would be this section right here. Between days 12 and 13, the temperature rose the most. It almost seems like it went from like 57 to probably like 95, which is going to be a large jump. This example says the graphs shown compare two quarterbacks' performances over the same 3 years. Each graph compares the number of touchdowns and the number of interceptions. So if we look at quarterback A and quarterback B, the darker bar is going to be how many touchdowns they had, and the lighter bar is going to be how many interceptions they had. It says which quarterback in a particular year had the biggest difference between touchdowns and interceptions. So which one had the largest difference means we would be taking the higher graph and subtracting the higher bar, and be subtracting the lower bar from that year. So if you look at quarterback A and quarterback B, the one that seems to have the highest difference would be quarterback B in 2002. If you notice, the difference between that bar is almost 15 between the number of touchdowns, the difference between the number of touchdowns and the number of interceptions. That's the one with the largest difference. So my answer is D, quarterback B in 2002. This next one says the table below shows the number of visitors to a theme park on each of the 4 Wednesdays in July. The park manager wants to predict the total number of people who will visit the park on the 5 Wednesdays in July. Which of these is the best estimate? So the total number of people in all 5 Wednesdays, if you look at this chart or this table, if you look at the numbers for each Wednesday under the number of visitors column, all of those numbers are really close and within about 100 of 2,000. So we could say that on any given Wednesday, there's going to be about 2,000 visitors in the park. So if there's about 2,000 visitors for each Wednesday, and there were 5 Wednesdays, we would do 5 times 2,000, which is C, 10,000 visitors total through all 5 Wednesdays in July. This says the frequency table shows the prizes offered in a school raffle. There are 1,000 total tickets in the raffle. The raffle prizes are broken down in the table. There's one $500 prize, 9 $20 prizes, 90 $10 prizes, 400 $5 prizes, and 500 free movie tickets. It says a local business purchased 100 tickets. How many free movie tickets should the business expect to win? I'm going to go ahead and set up a proportion. This is kind of a fairly simple problem, so you might have already figured it out. But I know that in all the prizes total, there were 500 movie tickets. So out of the 1,000 tickets for the raffle, 500 of those are going to win the free movie tickets. So I could write a ratio of 500 to 1,000. And if I want to know how many out of the 100 are going to be free movie tickets, I can set up a proportion and say 500 free movie tickets total out of 1,000 total raffle tickets equals X over 100, the number of tickets this business purchased. I'm going to go ahead and simplify. 500 over 1,000 simplifies to 1/2. So half of the 100 raffle ticket, or half of the 100 tickets purchased are going to be free movie tickets, which means my answer is C. To find the mean or average, you're going to add all of the data and divide by how many pieces of data you have. This example says Judy has test scores of 82, 75, and 78. What does she need to score on her next test so that she has an average test score of 80? Right now, Judy has 3 test scores that she knows, but she wants to know what she needs on her next test, which means we're talking about 4 total tests. I need to add the 4 tests together, divide by how many pieces of data we have. So in this case, I'm talking about the 4 tests, so I would divide by 4. And because I want the average to be 80, I'm going to set it equal to 80. So I'm going to assign the unknown test score, or the 4th test score, a variable x. So I have 82 plus 75 plus 78, which are the 3 known test scores, plus x, which represents my 4th test score that she hasn't taken yet, divided by 4 equals 80. The first thing I'm going to do is go ahead and add together the 3 numbers that you know. 82 plus 75 plus 78 is 235. Now what I need to do to solve for x is go ahead and multiply both sides by 4, which gives you 235 plus x equals 320. When you subtract 235 from both sides to get x by itself, you find that your next test score needs to be an 85. To find the probability, you're going to write a ratio of favorable outcomes, or what you want to happen, to all outcomes possible. And an example of this says a bag contains 16 red checkers and 16 black checkers. Anne removes 1 black checker and 2 red checkers from the bag and does not replace them. That's really important that she does not replace them. She then reaches into the bag and selects a checker at random. What is the probability that her checker is red? So first of all, I know that Anne is going to start with 32 checkers total. 16 are red and 16 are black. But then it says Anne removes 1 black checker and 2 red checkers, which means she's removing 3 total checkers. So I need to subtract 3 from 32, the total number of checkers she started with, and now there are 29 checkers in the bag. I need to subtract 2 from the red checkers, which means I have 14 checkers left in the bag. 14 red checkers, left in the bag. And I need to subtract 1 black checker because she took 1 black checker out of the bag, which means she has 15 black checkers left. The question that they're asking us is, what is the probability that the checker is red? So my favorable outcome here would be that I would pull out a red checker. There are 29 different checkers that I could choose from, and 14 of them are red. So the ratio is going to be 14 over 29C. This example says of the first 80 customers to use a gumball machine, 25 received blue gumballs and 35 received yellow gumballs. Carlos purchases a gumball. Based on this information, what is the probability that his gumball is neither blue nor yellow? So I know how many customers I'm talking about. There's 80 total outcomes that I'm talking about. I know 25 received blue and 35 received yellow. However, those are not going to be my favorable outcomes because it says what is the probability that his gumball is neither blue nor yellow. So what I know is that 25 and 35 were either blue or yellow. So 60 total were blue or yellow, which means 20 of them were not blue or yellow. So my favorable outcomes are the 20 that were not blue or yellow over the 80 possible outcomes. 20 divided by 80, or 20 over 80 can be simplified. 20 goes into both of them. 20 goes into 20 once, and 20 goes into 80 4 times. So my answer here is A. He has a 1 in 4 chance of not getting a blue or yellow gumball. This example says 7 students had a long jump competition. Each student jumped a different length. Joan was one of the students in the competition. What is the probability that Joan's jump was greater than the median jump length? Notice that they don't give me any of the jump lengths at all. But if you think of a set of 7 numbers, because we know there's 7 students in the competition. So I just wrote 7 X's down. The median is always going to be this 4th number, or the one that's highlighted in the set of data. 3 of the jumps are going to be greater than the median. That's always going to be true. 3 of these scores are going to be greater than the median if there are 7 jumpers. So my favorable outcome would be the 3 that are greater than the median, and my total number of outcomes would be 7 because that's how many students were in the competition. So my answer is C, 3 over 7. The last example says Tom throws snowballs at a target his dad made for him. The target is a square board with a circle with a 10-inch radius drawn on it, as shown below. Tom manages to hit the board every time, but his shots are totally random. What is the approximate probability that his next shot that hits the target will hit outside the circle? This is a probability question. Clearly, it says probability right in the question. What I need to find is my total outcomes possible. The total outcomes possible in this case is going to be anywhere in the area of the board. So this board is square. I can find the area of the board to find the number of total outcomes possible. Now be careful here because right now I'm talking about the whole square. If the radius is 10, that means the diameter is 20, and each side of the square is going to be congruent to the diameter. So the sides of my square are going to be 20 inches. To find the area of the whole square, I take my my side lengths and I square it. So 20 squared, or 20 times 20, is going to give me 400 square inches is the total area of the entire square. Now, it asks me what is the probability that his next shot hits the target outside the circle. So my favorable outcome is going to be this space outside of the circle that's highlighted orange. In order to find the area of the orange highlighted they look like kind of triangles in the corners of the square, I need to take the area of the square and subtract the area of the circle. So to find the area of a circle, I do pi times radius squared. I know that my radius is 10. Well, 10 squared is 100. So I'm going to take the area of my square, 400, and I'm going to subtract the area of the circle, which is 100 pi. Well, 100 times pi, if we're using 3.14, is just 314. So 400 minus 314 leaves you with 86 square inches for your favorable outcomes, or the orange highlighted areas in this case. My favorable outcome would be 86. My total outcome would be 400 square inches. So 86 over 400. Now look at your answers, and you'll notice that these are all decimal answers. Well, what I can do is I can go ahead and I can take 86 and I can divide it by 400, and when I do so, I get about 0.215. So my best answer here is going to be A, 0.22.